Let's see a balanced binary tree problem from LeetCode. So this is a easy problem. Let's try to understand. So this is saying that okay, we need to check whether this tree is a balanced binary tree or not. So the definition of the balanced binary tree is if these nodes, the left nodes and the right nodes, if you make a difference of left and right nodes, and if it is less than equal to 1, so that is the balanced binary tree, otherwise not. So if you see like from this node, if you see this left side height is 2 and the right side height is 3, so 3 minus 2 is 1, so it's a less than equal to 1, so this is a balanced binary tree. From here also again, if you see this left side height is 2 and right side height is 2, it's 2 minus 2 0, it's less than or equal to 1, so that's a balanced binary tree. But in this case, if you see the left side is a 4, the height is 4 and the right side is a 2, so 4 minus 2 2, it's not less than equal to 1, it's greater than 1, so that this is not a balanced binary tree. So we'll solve this problem using two different approach. Let's try a very easy approach, or we can say the brute force. Both are easy, but this brute force approach, and then we'll see the optimized way how to deal with this. So in order to know whether it's a balanced binary tree or not, first what we do, we go to each node and then find the height of this left, and then again find the height of right, and we do left minus left height and minus right height, and then we'll get the absolute value, and then we'll check that is the value is greater than 1, that's not valid, otherwise it's a valid. So let's find that. Let's write the code for this. So first we need to find out the height. So let's write the function find the height. Root and int. If you see the root go to nil, then height is return 0. Otherwise, if you want to find the height, then from this node go left left like this. So most left and then most right, and then we'll see the max of left right plus 1, and that's the height. So I'll just call this function height root left, then this is h1, just copy and paste, and this h2, and we'll check we need a function like find the max. So let's develop a function max. If a greater than b, return a, otherwise return b. So I'll check here, or I can just directly return 1 plus max of h1 comma h2. So that's the function to find the height. So like let's say we are here, and if you call this left, then come to this place, or maybe start for this example. Yeah, so from this example we call left, it will go here, and again right has to be called, but again another function call, and again it will call left, so it will most left, and from here we call the left, and in the left there is nothing, 0, and then for this also the right side also 0. So when you call for the call with the node 4, then we'll get this 0, like from here 0 0. So right for h1, and then for this 4, the left is 0 and right is 0, and then this the 1 plus max of h1 and h2, so 1 plus 0. So for this node we'll get the 1 height, from here 2. So like this is a very easy function to find the height. Okay, so we got the height. Let's call this function here. So before that we can check if root equal to nil, then return true here. Otherwise here height is called this function h1 and h2, and then we'll check the difference between these. So h1 minus h2, and I can say this is the difference, and we'll find the absolute value. So math, I can use apps function, but apps doesn't take int, so it takes float 64. So just I'm converting this to float 64. So we got the difference here. Now we'll check if difference greater than 1, then return false. Otherwise we'll call this each balance and root dot left and each balance root dot right. So if this scenario comes, then false. Otherwise, for each balance, it will go to the left side for this node also, and also it will go for the right side, and it check in if it is not this false situation, then at the end it will return true. But in any places where we find the difference and the difference is greater than 1, that height difference greater than 1, then that's return false. Accepted. Submit. Okay. So the problem in this solution is, uh, this is the recursion here, and each node, you go to the each node, and then we go for the left, and when you go to this left place, then it will come here, and again we'll find the left and right. So again there is another call, left call and right call. So this is, the end time recursion, and this is also again end time recursion. So this is the time complexity will be order of n square. So another way is, when we come to this place here itself, we find, the left and right height, and check the difference. And if you check the difference and the difference is uh, so check the difference and difference is greater than 1, then just return the false. So there itself we return the false. So those kind of things. So in that way, it can be solved with the order of n also. So let's modify this function. So here in a height function, I'm modifying in this place, and here I'm checking uh, this function difference. I use the difference function here. Check that if d, I say that okay, d is greater than 1, then return -1. And here also I'm checking if h1 equal to -1, then return -1, and h2 equal to -1, then return -1. So here itself I checked all this condition, and then at the end I will not call this function here. I do not need this check also here, but directly here I can call this function height, and I can pass root, and this is h height, and I can check if h equal to -1, then return false, otherwise return true. So that's the small change as I did. Accepted. Submit. So in this solution, this is the time complexity is order of n. Yeah, so this is the whole code. Yeah, we can see the Java solutions also here. For the simple logic, I have not written the code, you can do by yourself, but for this one, optimized logic, I have put that here in a solution. exact same logic what I discussed in a Golang program. So that's all for now. Thank you.